Thank you, and thank you for welcoming an sort of energy and an agricultural novice into an agricultural conference. But I'll try to give you the perspectives of energy into this. And let me start with a small quiz. Which is the bigger? I mean, one commonality with energy and food is that you could measure it in joule. So which one is the bigger? They're both big. If you look at the amount of energy produced in the world, it's a 5 with 20 zeros, 500 exajoule. If you look at the amount of food, and admittingly, this is the food consumed by humans. And if you add what is consumed by cattle or made into feed or others, I'm sure it's bigger, but that wasn't something I was able to calculate. But this one I could do myself with about 9,000 kilojoules per person for 7.8 billion people a day. That's 25 exajoule of food consumption. What does this tell? Of course, it's not so that producing energy is inefficient, or because the amount of energy you put onto a land for fertilizer or diesel or whatever would grow a lot when you produce food out of it. But it tells that the agriculture industry is actually a very small part of the energy industry. It's a very little part of energy that goes to fuel for agricultural use, including transport of crops around the world. And also we heard that agriculture is 30% of the world's emissions, but that's not due to the CO2 of the fuel they burn. It's due to the methane that we heard earlier here today. Anyway, both of these are big, and what is now happening is that we have a large shift because we have a war. And in most of the world, and in particular the low-income countries, as we heard from Schmidhuber here, the high energy and the food prices, they move the attention to the short-term priorities. These countries don't have time and focus to increase their pledges for the next COP meeting. They have more than enough, and they have inflation and recession on top of this for the short-term problems. In Europe, it's a little different, because Europe is doubling down on energy efficiency and renewable build-out. And they're not doing that because of the traditional reason of sustainability, but they're doing it of the energy security concerns, because energy security moved to the top priority in Europe. But luckily, they pull in the same direction as energy sustainability. So when you improve efficiency, when you improve renewable build-out, you also improve security. So the war is accelerating the energy transition in Europe, but it's slowing it down in the rest of the world short term. Longer term, the war is not really the one setting the pace for the energy transition. The falling costs of renewable, the increasing carbon prices, they are still the one that decides the long-term effort and pace of the transition. But I'll come into all this in the coming 15 minutes. But historically, we have had, and we have, an energy world which is 80% fossil fuel and 20% non-fossil. Non-fossil here means 5% nuclear and 15% renewable. Up to now, we have had an energy addition, not an energy transition, because there is no electric vehicle that reduces emissions. There is no solar plant that reduce emissions. The emissions are only reduced when you remove the diesel vehicle or when you remove the coal plant, and that has not happened to date. So we had an energy addition. But from now on, we will have an energy transition where the one is replacing the other. And as we see it, most likely with the expected economic, technological, and behavioral development, we're heading towards a 50-50 mix in mid-century. So we're moving away from fossil-dominated fuel, but not into a renewable-dominated one, not for many decades still. But I'll talk a little bit now on the energy trilemma. And if there is 1 year to talk about the energy trilemma, it's this year. I mean, the energy trilemma has been here for decades. But this year, all three triangles, all three corners of the triangle has got further momentum. And let's start with security, because that's not where we traditionally started. That has been left on the back burner now in Europe for many years, and never mind warnings that we were too dependent on Russian gas or others. It felt safe and comfortable. But now this has become the #1 priority in Europe, and it's all hands on deck to ensure alternative energy from the Russian one. Do we manage? Partly. We have an energy system which cannot easily replace the Russian gas because there aren't sufficient pipelines to Europe, there aren't sufficient liquefaction or regasification terminals to make sure we could have the gas into Europe. And now we look at both legislative, economic, technological, and behavioral measures in order to ensure alternatives to this gas. And we are partly succeeding, but also we are failing in the sense that European industry, especially if it's become a cold winter, will have to suffer. You will close down industries because there aren't sufficient gas. I guess most consumers, most farmers, they will have sufficient energy. But what can you easiest shut down? The industry. And that can also is the one with most threat to move out, and it could be permanent. So Europe is doubling down on renewable energy, on energy efficiency, and long term, that will mean that you secure a much more energy independent Europe. So you will see a Europe which is producing a more share of their own energy. The other corner of the triangle is the affordability. And even before the war, we saw that the prices started to increase, but that was related to Russian strategy. And we have had now, the last year, record high gas and electricity prices, as we saw here, but also they're currently 70% down from the all-time high for 2 months ago. And they might stop there, or they might go up again. The winter and the temperature this winter will decide, I think. In our model, we have left prices to stay high until end of 2024. Of course, I don't know how long prices will stay high, but 2 years is about what it takes for Europe to build new regasification import terminal, so you then can have sufficient amount of LNG coming in, and then you don't have to have these extreme high import prices, but rather get the normal LNG prices, which are higher than the Russian gas, but still lower than what we have today. The acceptability for the high gas and electricity prices are reasonably high, because you could blame an external party and not your own government. So in addition, the government are partly covering the high costs for households and businesses. So they try to shield the consumers from the worst effects of this. Let me also say one thing on affordability, which is not related to Europe. But when we buy the gas or when EU buy the LNG for record high prices, there are someone else who don't get that LNG. So what happens in Bangladesh and India and in Pakistan? They go back to coal. So that is part of the consequence. So that's one of the reasons why Europe could manage to accelerate the transition while the rest of the world cannot. The third corner, the sustainability corner of the triangle, have had high attention in Europe for many years. And Europe is the leading region for the decarbonization. There are increasing tensions within EU between North and South and between East and West. And let's remember that at the moment it's not one war in Europe, it's two. It's the war on the battlefield, and then it's the energy war between Russia and the rest of Europe. And these increasing tensions are giving us higher risk for hesitating on whether we need to have that tough sanctions against Russian energy, etc., which again is helping to win the other war or to lose the other war. But it is very fortunate that security and sustainability are pulling in the same direction. And with some few exceptions short term, like a little more coal power the first few years, we don't see a big risk for reducing, for increasing coal use in Europe longer term, but rather we see an increased renewable energy build-out, increased efforts for energy efficiency, a little bit on nuclear. Nothing like the French build-out after the oil crisis, and renewables. New nuclear cannot help us anything with the present crisis, but prolonging the present plant and delaying the shutdown, of course, can. And new nuclear will take 10 years or more. I saw they were to build a new one in Poland now. Completion was estimated, and it normally is delayed to 2033. I'll also take a little longer-term look on what do we see, and where Schmidhuber's graphs were 30 years backwards, mine will look 30 years forward. And that's, of course, much more uncertain, and I haven't deflated it or anything like that. But the transition is very different around the world. And if you sit in India or sit in Norway, it's very different. The story of energy transition is first and foremost a story of electrification. And electricity is also the part of the energy system where things are going well and where things are going fast. And we call it the growing and greening of electricity around the world. This picture shows the European electricity mix. And we see that it's already relatively low on fossil fuel. It's only 25-30%. And by mid-century, we expect that to be negligible. But we will have the growing of wind and of solar, and wind is the bigger. In Europe, almost 50% of the power is likely to come from wind, and a lot of that from offshore wind. And it's the continent with largest wind share. Of course, you have then about 70% of the energy is coming from variable energy, where the wind doesn't blow and sun doesn't shine all the time. So that gives us a lot of challenges on the electricity system. But still, so that means that even though it's cheaper and cheaper to generate a kilowatt hour of electricity, it's not necessarily cheaper for the consumer, because you also have to pay for a much more complex grid. Still, it's a success story from a decarbonization perspective. We shouldn't neglect the biodiversity and other challenges in this, but this is doable. There is no other areas where we see an as big change as in the gas forecast we have this year. And in Europe, we actually see 25% lower gas consumption in 2030 and 45% lower gas consumption in 2050 than we did a year ago. So when Europe now is building itself out of the short-term gas crisis because of unavailable or not sufficient gas, then they're also long-term build themselves into a less gas-dependent region. Because when you now build new buildings, you build them with heat pumps instead of gas boilers, for example. So we do see a long-term shift on this. Also globally, there is a much lower, significantly lower gas demand in 2030 and 2050 in our forecast now than we saw a year ago. So although the war is not the most decisive factor for the long-term outlook, for gas demand it actually is. And then is this good or bad for the environment? It's both, because gas, the reduced share of gas globally is partly replaced by more emitting coal and partly by less emitting renewables. So for the climate, it's maybe a zero-sum game. And what about hydrogen? We had a hydrogen forecast coming out this year, and this is European hydrogen demand. And we see that it's considerable today, and it's used in refineries and for ammonia and fertilizer production. But hydrogen as an energy carrier don't exist almost today. It will come, and it will come in 3 sectors: in heavy industry, the blue one here, in buildings, the green one, and in transport, the gray one. And the latter will typically not be in as pure hydrogen, but as ammonia or e-fuels. And that is probably the only other big consumer we will get for ammonia will be shipping. And shipping has potential to be a bigger consumer of ammonia than what fertilizer production is today. The green one here is relatively European specific. In the rest of the world, you will see mostly on the blue one and on the gray one here. What does this do with emissions? Europe has a very ambitious strategy of reducing CO2 emissions with 55% from 1990 levels in 2030 and net zero in 2050. We don't find that they manage, but still we find that they reduce it a lot. And our findings is a 48% reduction of emissions to 2030 and an 85% reductions to 2050. So to summarize, the high energy prices and the energy security focus that now dominates due to the war in Russia are having a lot of short-term consequences, but long-term it's not the most decisive factor for the transition. In Europe, we are able to accelerate the energy transition as a consequence of the war because it makes us double down on energy efficiency measures and on renewable energy. In the rest of the world, this only worsens the present situation, and the priorities are now the short-term focus. And despite urgency of action from Guterres' Code Red for Humanity and the 3 IPCC reports coming out the last year, we still see global CO2 emissions remain at present record high levels. We only see a reduction of about 5% this decade and 45% through to 2050, which is very different from the net zero 2050 imperative we need to reach 1.5 degrees. And if we as we look towards the end of the century, most likely, as DNV sees it, we expect the technological, political development will be around 2.2 degrees of global warming. That was all I had to say. You can download reports here from our website. Everything is freely available. Thank you.